Right, in the previous lecture, we've gone over principal component analysis. That's what I provide the underlying logic. Today, we're able to assign the first homework and to continue with another topic. So this is about unsupervised learning. And typically, when we talk about unsupervised learning, we talk about clustering. Okay? And we'll start with it. So what is cluster analysis? In other words, it is grouping the data. That's the general definition. So it is finding groups of objects that the objects in a group will be similar to one another and different from the other objects in other groups. So our goal is to make sure that intra-cluster distances are minimized and inter-cluster distances are maximized. Typically, we pick distance measure or similarity measure ahead of time and use it to determine the similarities. Unsupervised learning or clustering has many applications. Marketing, one case. For example, you may cluster customers based on their shopping behavior and then send customized advertisements to those groups. Land use, okay, from satellite images, we like to analyze the agriculture area, the urban area, the rivers, etc., how they are used. So it's a clustering by just looking at the images. Insurance, so we may identify customers based on their cost. Tip planning, so in any application we could apply clustering. I already mentioned that a good clustering method will produce high quality clusters with high inter-cluster similarity, low inter-cluster similarity. And the quality of the cluster depends on the similarity method, okay? and the method itself. So both are important. So what is not a cluster analysis? Supervised classification. So if your data has labels, and if you are using the labels of the data, classes of the data for your analysis, that is not cluster analysis. Simple segmentation. For example, you have a directory of students at the university for letters A to C, one group, B to F, another group, etc. So that's not cluster. That's simple segmentation. Or results of a query. So you may generate a query and find the students who take advanced machine learning course, and that's not a segmentation. Graph partitioning has some relevance, but areas are not. There are two ways to define the similarity and dissimilarity, because you are aware of it. These both use actually, depending on the application. So similarity measures how alike two data objects are, and similarity values are higher when objects are similar, and the similarity values are lower when objects are different. And typically, similarity measure is within the range of 0 to 1. 0 means they are totally different. 1 means in this, if the range is 1, they are exactly the same. The similarity measures how different the objects are. Lower when the objects are very similar to each other, and it can be very high. And typically, for this similarity, we may not have an upper value. Okay. So it could be go out to infinity. As an example. Proximity is a term is also used to mean similarity or dissimilarity. So it covers both. If you don't want to mention similarity or distance, you can just use proximity. So these are general structure of dissimilarity and similarity matrix. Okay. So what you are seeing in a distance matrix. So here each row and each column is an object. Okay, so we are measuring the distance of the first object to the first object. In distance matrix, the diagonal will be 0 because the distance of an object with set is 0. They are exactly the same. On the other hand, for the similarity matrix, the diagonals will be 1 because similarity is high when the objects are the same, right? So if the range is 0 to 1, the highest value is 1, so we have 1s in the diagonal. And others, you just have the distance between 2 and 1, distance between 3 and 1, third object and the first object, distance between the third object and second object, and so on. Typically, in many cases, it's a symmetric matrix. So, upper side on the bottom left and the upper right will be the same, right? But symmetric. That makes typical. The other one is similarity. It's the same way. We measure similarity from 2 to 1, similarity from object 3 to object 1, similarity from object 3 to object 2. And this is another example for nominal attributes. We have either, if you remember, only 2 operations: equality and equality. So that's the only thing. We don't have ranking of nominal value. So if you are using distance measure as an example, if the values are the same, then the distance will be 0, otherwise it's going to be 1. For similarity, it's going to be opposite. If the objects are the same, the similarity will be 1. For this, otherwise it's going to be 0. For ordinal, this is an approximation, and it's not guaranteed to work. If you know that the values, their values P and Q, you may rank the, because we have, for example, that average good. Okay, 3 values, 0, 1, 2 in this case. So what is the distance between good and average? So you can use this type of formula. The first left-hand numeric values 0, 1, 2, and apply. Okay. And in this case, you can use similarity as 1 minus distance. For interval or ratio, for distance, you can just use a difference. For similarity, there are several versions. So you may apply e to the power minus d, or is equal to opposite of distance, 1 over 1 plus d, or you normalize. Look at this like maximization, between 0 and 1, and subtract from 1. So these are some samples. Just to show how they look like. So if distance d prime is equal to d over 1 over d, and distance will be 0, 0.33, 0.67, 0.90, 0.99, 0.99. So why do I do this? Original distance does not have a range. It can go up to infinity. But if you want to limit the range between 0 and 1 for every value, then you can use this formula. D is equal to d prime, d over 1 over d, and for 1000, it will be 0.99. This still has a limitation, right? So if you look at this for 100 and 1000, the value is not that big. For similarity, 1 divided by d plus 1. If distance 0, 1, and 100, similarity will be 1. 0.5, 0.09, and 0.21. This is a method. Sometimes you want to switch from similarity to distance or from distance to similarity. And another one is taking it to power minus b, and similarly is 1 for 0, 0.37 for 1, 0 for 10, 0 for 10. You may wonder why I go over this. In the first slide or in the second slide, when I started, the performance of clustering depends on two things: distance similarity measure plus the method. Okay, so that's why this is an important. So what are the common properties of a distance? These are, well, these could be considered good properties, or we are going to name them metric. So firstly, if two objects is for distance, if distance P and Q are 0, only if P and Q are the same. Positive definiteness. Otherwise, the distance is greater than or equal to 0. Or in general, it's greater than or 0 for all of them, and it is only 0 when they are the same. The other one is symmetry. The distance from P to Q is the same as from distance from Q to P. That's symmetry. And the third one is the angle inequality. In this one, distance between P and R. So just to show it. So this is P and Q. This is distance between them. And then I add, let's say, another point called R. So if I draw this, the distance from P to Q, it should be direct distance. Be less than distance from the summation of distance from P to R and the distance from R to Q. So that should be smaller than the summation of those two distances. So that's triangle method. This is very important property. Set difference. Let's think about it. So we want to find the distance from A to B. So it's a set difference. So what we mean is that we have A and B. So if you have something like this, it's not symmetric. The distance of A to B, if I define based on the size, A to B is 4, B to A is 3. So this is an example of a non-symmetric distance. Or, but we could make it symmetric in this way. Distance of A to B is summation of size A minus B plus size B minus C. Time is also considered not metric. For example, from 1 p.m. to 2 p.m., how many hours do you need to reach 2 p.m. from 1 p.m.? You need 1 hour. But if time is 2 p.m., to reach the next 1 p.m., you need 23 hours. But you can see examples of non-symmetric. Because we usually think that they are symmetric. Could you, from real life, could you give examples of symmetric distances? Yeah, distance typically, yeah, usually. You said distance, right?
Between me and you. The distance between my position here and your
positions, yes. Yeah. What else? From real life?
Shape of some object. Shape of object.
Shape of object. Give me two sample objects so that we can check what are the objects you think.
Yeah, that. The shape is fixed. Symmetry. The shape.
Shape is symmetric, okay. But we should give two objects. So we measure the distance or symmetry between two objects. So yes, that object has the rectangle has a symmetric edges. Yeah. But what are the two objects? For example, let's say I believe most of you might be driving, right? So when you drive between your room and the school, and then that's one way when it comes to, and then you go back. Do you think that is symmetric? Yes. So we need to be very clear on the definition. First, how do I measure? When I say are they the same? My first question is in terms of distance. Are they the same? Yes. In terms of time, does it take same time to come here and to go back? It depends, yes. It depends on when you are driving. So that could be an example. Or if you are climbing a mountain, the distance is the same as the distance you are coming down, right? But the time to go up and the time to come back could be different. So these are just examples. So the most common distance measure is Euclidean distance. Okay? So this is almost de facto standard. If you don't know which distance measure to use, we usually use Euclidean distance. But you should be aware that this is sensitive to the range of values. Data is not normalized. The data that has a large range will have more impact than distance. Okay. So in this case, we have four data: P1, P2, P3, P4. So you can plot them. These are the points you're going to get. And what you do is, when you find the distance between P1 and P2, you take the distance of each, take the difference of each attribute and take the square of them, 2 minus 0, and take the square root of this distance P1 to P2. So from distance P1 to the distance from P1 and P2 will be square root of. So that's one case. So you can also do it for 2 and 3, or 3 and 4. 3 minus 5 square plus 1 minus 1. 3 minus 5, 1 minus 5. Distance P3, P4, you are going to get 4 plus 0, you are going to get square root of 4, which is 2. So you can see that. Any questions? So this is just introduction before going into clustering analysis. At least you need to know at least one distance measure. Right? That's why I go over. So the next part is I'm getting into clustering now. The notion of a cluster can be ambiguous. So maybe what I should do is, how many clusters, in your opinion? 6? 2? Yeah. Any other? So it could be, if you say 2 clusters, these are the clusters. If you say 6 clusters, okay, probably these are the clusters. if you say 4 clusters, most likely it will be the clusters. Most likely. So it is not clear by looking at data. It's hard to say how many clusters there are. So that's not a solved problem. So there are ways, but still, either you need to provide a number of clusters an input, that's one thing, or you need to provide another parameter that defines what is a good cluster, and the system will develop the cluster code. The clusters are classified as well-separated, center-based clusters, contiguous clusters, density-based clusters, property or conceptual, or described by an objective function. The easiest one is well-separated clusters, and it's not going to be, I'm going to see it in real life. So in this one, all objects in a cluster are closer to each other than any other point in any other cluster. Okay. For example, if I pick a point here, this region, all the points in this cluster, blue cluster, are closer than any other point in the other cluster. So all the others are very far. That's why this is a well separated. The other one is center-based cluster or prototype-based cluster. The definition is in center-based or prototype-based. So when you have a cluster like this, you have a center, the center point. For red, this is somewhere here. For blue, this is somewhere here. For green, this is here. Or yellow, this is somewhere here. So you assign points based on the distance to the center. This red point is assigned to this center, this cluster, but this blue is closer to the center than the center of the red. Okay? So you see that although the objects here at the boundary of this red circle and blue circle here are very close to each other, they are put into different clusters. This could be a problem, example. But this is usually a very popular thing. Another one is contiguous clusters. So this is going to solve the problem of the center-based clusters. Look at this. So these are all points. So we look at the neighbors. The neighbors should be in the same cluster. So all the greens will go into the same cluster because we can follow them. All the blue dots will be in one cluster. All this pink will be in another cluster. This is contiguous. You look at the distance. The distance is small, you put them in the same cluster. That's the logic. So here, for example, for these two, you have one bigger cluster. But this will be two different clusters. And for this C shape, all the data are connected to each other. They are going to be in one cluster. This blue are two different clusters normally, but there is some noise between them. Because of the noisy data, they are connected and they are put in the same cluster. So that's the limitation. If there is noise could make different data to be close to each other. To overcome this problem, we have density-based cluster. So you look at the density of points. So the noisy area, you don't have enough density, you ignore them, you consider it like a noise, but they could be separated. And they are going to be in two different clusters. Shared property. It is hard to, in this case, there are two clusters, okay? One of them is this circle, the other one is this circle. Okay? Two clusters. The data belongs on this circle belongs to the first one. The data on this area belongs to the second circle. If the data appears on intersection like this, then it's going to belong to both clusters. The difficulty here, this data here, if you look at here, this belongs to this second circle, although it is appearing in the middle of the first circle. So in this case, typical distance similarity measures will not work because this area is closer to the first circle. The major clustering algorithms are typically called partitioning algorithms. It's one of them. That's what we are going to start today. And there are hierarchical algorithms. So partitional or partitioning means each data will belong exactly to one cluster. It cannot belong to multiple. That's the base case. So you are going to split like this. So that's a typical grouping. Okay. So when we say clustering, the first thing that comes to our mind is partitioning class. So today I'm going to talk about k-means clustering as an example. Have you heard k-means? Yes. Have you used it before? Do you know what the algorithm is? No? How it works? Okay. I don't need to cover. That was a tricky question, right? Of course, I want to cover, even though it's simple. So there are several ways of showing this algorithm. Normally, what we do is in k-means, we have a set of data. K is an input parameter. So you need to specify the number of clusters. You need to say this, I want 3 clusters, I want 5 clusters. That is provided to algorithm. And in the basic k-means, you select k of the points as initial centers. So that's the same. You just select random. Then you assign each point to the closest center. You assign each point to the closest center. And then after you make the assignments, the clusters are formed, and then you recompute the cluster centers. You compute the centroid, the cluster centers.
How do you select the initial point?
Typically random. But there are better ways than selecting random, or there are better ways of selecting random. And this continues until the centroids don't change. Okay. So this is just a sample. So you can look at this. So these are the points, 2D points. And these are the 2 crosses you see here are the centers we select initially. I think what they have done here is they've used circles and dots. Circles belong to one cluster, dots belong to the other cluster. And after you make the assignment, you see the area here. When you recompute the center for this one, the center will go to somewhere here. And for this one, the center will go between these two. Because we have 2 objects. That's what you see here. Then we again assign the data points, okay, for this one. It's going to stay somewhere here, but some of the points that were not here, they're going to come across the centroid. And then you recompute the new centroid again for the dots and circles, and then see what we get. I'm going to show more examples. But this is another example. So in this one, you see that there are 3 clusters. optimal clustering. Sometimes you may get suboptimal clustering as well. This is just a visualization. So in this scenario, we pick 3 points. You see those 3 points right here. So if we assign the points to this, so this red will go assigned to this one. All the points blue you see will be assigned to this cluster, and all the reds will be greens will be assigned to this one. Automatically, when you recompute the center for the green, it's going to come up somewhere here, or blue is going to come up somewhere here, right? That's what's going to happen. So you said the center is moving properly. Then we have new assignments. The red cluster is growing, and it's growing. Then we have green and blue at the bottom, and so on. This is what we get. So it's a simple application. So let's do a real example of how it works. Data has typically multiple attributes. I haven't used one attribute. Okay? So it's a one-dimensional data. So give me some numbers. Let's say it's going to work on. Give me a number, not too big, okay?
1 and 2.
1 and 2. More numbers.
5, 7.
5, 7. They don't have to be in order, but that's fine.
3.
9, 3. 9, 3.
9, 3. How many clusters? Let's see. Let's get 2 more.
4 and 6.
I'm not going to do this one because I don't see any cluster. 1, 2, 3, 4, 5, 6, 7, 8, 9. What are the clusters? You need to have clusters. So imagine that. Let's start with this one. Yeah, 1, 2. Okay, we see that used to be one cluster, and let's keep that a little bit different. Okay, let's have some gap. 9, 10, 8, and then let's have 7. So you see that we have 2 clusters. So now we can work on it. So we can see that our algorithm will work on it. So normally we select the clusters randomly, right? So I'm not going to, if I select 2 as one cluster, centroid, and 7 is another one, it's going to work automatically. So I'm going to consider a little bit worst case. Okay? What if I select random initial centroids from the same cluster in the beginning? There's no guarantee that you are going to have one initial centroid per cluster, right? We cannot guarantee that. Let's consider a little bit worst case. So let's say the worst case is I'm going to pick 9 and 10 as my initial centroid, but they are extremely largest. So what I'm going to do is, I'm going to compute, find the closest center for each data. Is 1 close to 9 or 10?
9.
9. 2?
9.
9?
9.
9. 10?
10.
10. 8?
9.
And 7.
9.
So initially, all the points are assigned to 9, only 10. And what I'm going to do, I'm going to recompute the centers. Okay, so let's recompute the center for this cluster. So how do I compute the center of it? 1 plus 2 plus 9 plus 8 plus 7 divided by 5. So what is it? And average, yeah, what is it? Give me the number.
5.4?
5.4?
Yes.
5.4 for this one. And for this one is 10, right? We have on the data. Again, I am going to reassign all data points now. So I have two centers, 5.4 and 10. Okay. So I'm going to check, is one close to 5.4 or 10? 2, 5.4, 9, goes to here, 10 will go to here, 8 will go to here, 7. So after this, I'm going to recompute the centers. 1 plus 2 plus 7 divided by 3, 3.3. And here I have 9 plus 10 plus 8 divided by 3. I got it. Right? So 3.3 and 9 are my new centers. Is 1 closer to 3.3? Yes. 2? Yes. Where is mine? 9. 10 will go to 9. 8 will go to 9. 7. So I'm able to generate my clusters. Although I started with a wrong initial clusters. So the system can adapt itself. Okay, so this is the power of things out. For when you measure distance here, you just do this, right? 9 minus 1 is 8. Okay, that's what you did. But your data could be two-dimensional. Okay, like your data point 1 may be x and y values, like 2 and 3. Point 2 could have 4 and 5. Then you are going to use the measure like a gradient to find the distance, whether it's closer to the first centroid or the other centroid. Any questions?
Just a clarification. In such case, it's just gonna be d of p and p2, p1 and p2, right? Like the distance between p1 and p2 for this pairwise.
Yeah.
Okay.
What is the question? Oh, I didn't get it.
Okay, I just said it's a clarification, not a question actually.
Okay.
You actually stopped here, so I was expecting you to like finish the statement for this P1 and P2. When
You are
have
going
these
to
ones.
compute the distance P1 and P2. For example, the center will be here, let's say, this could be first initial centroid, this could be the second initial centroid. Other points could be, I'm just making up 5, 7, let's say 1, 2, etc. If these are your initial centroids, then you are going to have 2, 3, you are going to have 4, 5, then you are going to find the distance of this to this one, distance of this to this one, and so on. You are going to find the distance to each centroid.
Okay.
Now, I'm going to talk about the assignment. I think there are 4 assignments. This will be the hardest one. That's my opinion. Okay, but maybe it's going to be the simplest one. Actually, give me 1 second. I forgot to update this. I'm going to open up from my original.
Video,
What is it?
like, can you just, like, videos, like YouTube videos on PCA?
You could do that as well, but you need to write a program.
She's asking you like you do.
Instead of like articles, like, can we do also video?
The answer is yes. But that's harder, right?
Yeah.
You need to generate the caption
That's much
of the
harder.
document, but it's possible. It's that what will happen is most likely your your program will run a little bit longer for text extraction, but it's possible. Yeah. But I don't say I'm going to show how it can be done. So I open this up. Okay. Further feature elimination is being discussed. That's one topic that's been discussed. Another one is you should not use PCA if you are comfortable making independent labels. That's effective. You should not use it in that. That's one topic covered. Okay. So I wanted to provide me topics covered in those selected documents. And that number is K. If you say K, you are going to your system will pick up, let's say K centers. First, you are going to generate K groups, and from that K groups, you are going to get K centers, and the centers will be what is covered over there. So, but I'm going to give you, I mean, this is not, I'm going to give you some starting points, but that's the project, okay? But overall, what I'm interested is how you are going to write the k-means. The k-means part is the core part of the grade. Now, let me go back to this assignment. So this is the general purpose of the assignment. You are going to use large language models, okay? And they are already available, but usually starting point is typically the most difficult starting point. So use your favorite search engine, select the 10 articles, and then use apply k-means plus identifier. But before you move your k-means algorithm to this domain, you should test on a smaller data set. I provide a smaller data set called KM test for you. You can look into it, you can plot the data, and make sure that your algorithm works first. Okay. And for this one is, now I'm going to provide a little bit more detail. There's a library called LangChain. Okay. LangChain. So you cannot start with direct, because you need to have some starting point. Okay. You need to use some available resources. So I'm going to open this document. I'm going to explain the logic behind it. So this is actually designed for question answering, okay? But it has many common parts. Loading is the same. So you need to load the data, read the data from a website. Okay? You need to split the document into smaller parts. Okay, that's what you should do. You need to store the data. Okay. Retrieval at a level, yes, you need to do some type of retrieval, but not very critical. But you can think of it. You need to generate an answer at the end. This is what's being discussed, and you may have a conversation at the end. But the conversation is not required. Among here, loading, splitting, storage, and generation. Step 1, 2, 3, and 5 are critical. So I'm going to go over what it looks like. Okay?
So in means the library will do it for us.
I'm going to show it to you. Yeah, I'm going to show what it does for you and so on. So library has something called web-based load. If you provide the web page, it's going to load the data for you. So you don't need to write anything to parse. Okay. And it can generate it can actually index the data. So there's a vector store. You can use this vector store to create some information that's going to organize the data. So the first part is loading. So it is in this example, they store in a database, and the system may query what is the composition. It's going to try to find that expression in the document and then give you the answer. This is not directly relevant. Okay, I'm just showing what's covered. So there is loader and data is load data. Now this part is splitting. So normally you would like to split the data into chunks because it's a huge document, right? You may want to consider splitting based on sentences, paragraphs, whatever. But here, the method is used is they want to use fixed size chunks. Okay, as an example, 500. So what you should think is when you select the chunk size, text with a number of words, what is the size of a sentence? You should think about that. Okay, let's say the size of a sentence would be 50 words at most. Okay, sometimes if you say select 50, it may have 2 sentences in it. Okay, but when you split at 50, at every 50 you select have a chunk, another chunk, and another at 50. The sentence will be split from the middle. There's a risk of it. Okay. Then there is a chunk overlap. Okay, you make sure that at least 10 words are always overlapping, so that the sentence is either completely appearing in one chunk or the other chunk. So that chunk means overlap means you don't want to split exactly from there, but you when you start the next chunk, at least 10 words are coming from the previous chunk, so that the sentence are covered. Doesn't make sense? Okay. Then this is splitting part, so you can split in this way. This is the command. Okay. All split, so you can have it there, right? Then
Can we?
Yeah.
Can we just split by sentence?
I'm going to you could, but there's a risk of it. Okay, you could, but there's a risk. Okay. The thing is, you are going to generate some features from your sentence, right? And if your sentences have different sizes, so you are going to have different number. You may have different number of features. So how are you going to compare your data if the sentences have different number of features? Okay, so that would be a challenge. It is fixable, but it's a little bit challenging. Since this library works in this fashion, I recommend you to go in this way. Okay. Then there is something called vector store. You could use this vector store to store the data, okay, to generate data. Here is the main issue. There is something called embeddings. Okay. Embeddings is basically it's a feature representation. If we have 20 words, let's say, as a chunk size, if you provide this embedding function, OpenAI embeddings, it's going to generate a feature vector for you. I don't know the size, maybe the feature vector size is 1000. A feature vector that represents that 20 words. And for every chunk, you are going to have that feature vector, feature generation. Okay. So OpenAI is GPT. Okay. So it is GPT-based embedding representation. So they have features for word representation.
What is the example feature?
It's a vector. I can show it in
It's
maybe.
a word-based embedding, right? It's a word-based embedding.
Word-based embedding, yes, word embedding. It's a feature vector with a numeric number, like 0.1 is the first value, 0.2, 1.6, negative 1.2. So it's a numbers like this. It's going to have a representation for the sentence chunks. So this is also for OpenAI. You need to have an account to use OpenAI embeddings. Has anyone used OpenAI? Okay. But when I tried OpenAI, it asked me credit card. Okay. So I think the first 100 cases is free. Then you may be charged. Okay. So I don't suggest using OpenAI. I cannot. I mean, it's your risk if you want to do it, but it works smoothly. Okay. There's an alternate, and the alternate I'm going to show in a few minutes is Hugging Face embeddings. That's the one that I'm going to use. Okay. I'm going to show. So what you understand so far is you can load the data from website. You can also load the data from YouTube. You can get the transcription and then use it for this purpose. Okay, so it's possible. You can work on the on that one as well. So you can load the data. You can split it into chunks, and thirdly, you can get the features, feature vector or vectors for the data. So these are the sources that where you can get the data. Okay, so you can see it's very wide set of. Okay, so you can read from basically any. This is a question, but we are not going to do questioning the system. We are not going to do retrieval. And there is, but in this part, here's what it does. So you can refer to this. What it does is, when you go over this document, because it's going to help your assignment, you ask a question like, what are the approaches to test the composition? And this is the question that's given to this system. It's going to generate the embedding, and it's going to compare that embedding with all the embeddings of the chunks, and it's going to find the closest chunk for you. Okay, that's retrieval. This is your question. What are the approaches to test the composition? It's going to generate the embedding for this one, and it's going to generate compare with embeddings with the distance function of all embeddings of chunks you have. Okay, but you already split your data into chunks. Then it's going to find the closest. Okay, as an example. But your chunk will be a weird split sentence. For example, if I pick this one, let's say it's going to be something like this. Okay, this one chunk as an example. Implement a common method, but what is the beginning? What is the ending? It's not there. Okay, you don't see it. So typically, it's going to be longer than this, or it could start like this. Okay, but not limited to and something. You give some incomplete sentences to the chatting, the conversation. It's going to generate a good sentence for you. It's going to reorganize what you mean by this one. It's going to generate a sentence. Okay, and then once you find the center of your cluster, it may have an incomplete sentence like that. You give it to a chat tool, and then it's going to generate, summarize or rephrase that statement for you, and it's going to explain what it is. Okay. But that's the last part of the assignment. Okay, so this is generate. So this is generate part. So it uses GPT 3.5 turbo. So this is the query, and then it's going to generate an answer for you like this. The last part, I don't going to go in that part is chat. In the chat version, what it does is you may have a conversation. For example, you ask a question, you get an answer based on the answer. Well, how is that possible? Okay, you can answer, and the system will remember your questions from the past and answers. So chatting is that part. So if I go back here, you may start at this. I believe you should be able to start these initial parts. Step 1, loading. Step 2, splitting. Step 3, storage. Step 5, generation. So if I go back, the assignment, so that's length chain. So I said that you can use Hugging Face embeddings. Okay? For Hugging Face embeddings, you don't need to create an account on Hugging Face. And you are going to use a token. It gives you a token, and you are going to use that token to generate the embeddings. And there is a part called paraphrasing text using transformers. So you can use this part rather than the part from that length chain. You can also use how to paraphrase text using transformers in Python. Then I'm just going to open that part. So there is a code. They are using the Pegasus transformer. The code is simple, but even running this is a challenge. The configuration is the biggest challenge. And if I see an example, okay, so in this example, they give a sentence like this, and they want 10 sentences in the output that's going to rephrase this. So you can provide your center of the cluster, provide it, and then ask the system to rephrase it. Yes.
Center of the cluster.
So you are going to find the topics that are covered in those documents, right? So the centers of the cluster will be a topic that is covered. So it's going to be a chunk, basically. So the chunk. So you ask the system to rephrase the chunk that appears in the center, and that's going to be your topic.
Wait, so the center is the chunk.
Because what we are doing here, you are dividing your data into chunks, right? So let's say you have 1,000 chunks. And I say you cluster this 1,000 chunks. So when you have 10 clusters, each cluster will be composed of chunks. And when you find the center of the chunk, it's going to be a chunk. It's a chunk. Yeah. But here's one thing you should, this is the critical part. When you are done, as you reach to a point on k-means clustering and you find the center, we don't use that center to generate the expression. You find the closest chunk to that center. Otherwise, it could be a random feature vector. Okay, you find the closest data to the center. You are going to use that chunk to replace it. Okay. Questions? Very simple. Everything is there. Everything is there. You need to just run it. You need to just run it. If you need additional time, let's say you work because we have a longer weekend now. If you have additional time, next Wednesday, let me know. Okay, I can extend it. Understanding, I could just give numbers, and do k-means algorithm, and then it's going to be this thing. Now there are two things. I try to make a switch. Say classical machine learning, but I want you exposed to the modern machine learning. So that's going to happen. Yeah.
So actually, maybe because I'm new to this,
Yes. Yes.
The question you write, is the system going to read it like a sentence, or is going to read it like just letters?
Repeat your question.
Okay, so there was a time you showing us a code in the
Yes, there's a, what is the test composition?
So there's a place you write question,
Yes.
then it's in a code, then you wrote something in there.
Yes.
Is the system going to read it as text, like A, B, C, so, or it's going to read as
It's
text?
going to understand your question.
Okay.
You provide the text sentence. It's going to understand what you mean. It's going to generate the vector, and you start comparing that vector with the charts. That's what you are.
Yeah, I just want to know. So
What's the
if-
vector and what's the?
So the question.
Yeah. So
As a-
give me what. Yeah. I want to show. Now I want to show my example. Okay.
Yeah, but if we replace it.
So let me tell you. When I say chunk is this. As an example, this is chunk. This is the first chunk. This is the second chunk. These are chunks. When I say embedding, it's a numeric representation of it. So I'm going to show you, maybe it's 5 minutes left, but I'm going to show my example, so it's going to be. I use Anaconda for my environment. So to use Hugging Face, you need to have some part like this. So this is a initialization phase. So let me show mine. So I have already my profile. I have there is a read token, write token. You could use any of them in this case. I'm going to use this one. So to do this, I'm going to go here. I'm going to run this cell. It's going to ask me my token. And run it. And then I said that this is going to be my token. Okay. Then these are the libraries I'm going to use. Hugging Face, Hub. Then I'm going to change etc. So let me run this. These are just important libraries. And here, this is the same thing. I just copied from that place. But what I did was I have 2 documents. So if you have 2 documents, you have to provide it in a brackets, tubular brackets. Okay. So I have 2 documents, one separated by comments. So let me run this one. So it's running.
What is the hard thing about this assignment?
Configuration. Configuration.
Make it possible to run, like debugging.
For example, what's going to happen is you are going to come to a point. This is not fun. It cannot recognize this function. Okay, something. Oh, you need to install this. Okay, you install it. Then the next thing we say that when you install this library, but it's not compatible with the library you installed previously. Okay, you need to go ahead and change that. Okay, so these are the things that you are going to face.
So what is the criteria of grading you?
I'm going to focus on the correctness of the k-means mostly. I do not grading part.
Yeah, grading.
I'm going to mostly focus on the k-means part, but the other process also.
K-means part mean, is it correct or is it, does it need to be, does the content generated needs to be convincing?
That part, it doesn't very, it's not very critical. The output may not be nonsense, maybe. Just don't worry about it as long as your code is correct.
The sentence generated is for all articles, or each article you need 5 sentences for that.
So what's going to happen is you are merging all documents. You are finding clusters from all those documents. Then you are analyzing the clusters. You are doing the clusters. So a cluster may have chunks from multiple documents. That's what's likely to happen.
So what the machine will do? I'm thinking that okay, it like say it could read 10 documents, right?
What is that?
Like after I did it, like
Yeah.
let's say it read 10 documents.
That documents, yes.
And then what it is going to do, what's the output should be.
Yes. So let me summarize that. That's the core. So if that part is not clear, you don't know what you're doing. Okay? I am, when I do the search, what I do normally, if I want to learn PCA as an example, I need to go and read each PCA document one by one. I need to read the first PCA document, second PCA document, third one, fourth one, fifth one. I read all of them. But I say that, but probably 50% of the topics on each document is overlapping, most likely, right? 50% of the topics are overlapping. I don't want to go and read again, overlapping parts again and again. What I want to do is, in those 10 documents, what are the topics that are covered? That's what I want to know. Okay. So when you do clustering, it's going to group your data into 10 clusters, all those documents into subparts. Then I need, okay, this is the one topic covered, this is another topic covered, and so on. Okay.
And then it will make a summary.
So when you find the chunk, the center of each cluster, you give it to the ChatGPT and rephrase this sentence, because chunk is not a complete expression. It's going to generate a sentence for you. Okay? That's the expectation.
So we're providing the centroid for summarization, not like the entire chunk or the entire cluster, just be the centroid.
The centroid, yes. Actually, closest chunk to the centroid.
I wish I could knew the school, then I don't have to read that.
What is it?
I wish I could knew this in school, then I don't have to read that.
About the document, you don't need to read the documents.
Professor, do you have the school?
You are, it's recorded, right? So you can just type from.
It's so okay.
Some of them is kind of, the critical part for the one that I want to show. Why I show it to you? I use Hugging Face, not OpenAI. So the website I showed earlier is based on OpenAI embeddings, but I'm using Hugging Face. I am using some models that from the Hugging Face so that you see that. Okay. So let me see. So this is coming from the other one. This is splitter. So you already see that I put some overlap. 500 is too many, in my opinion. And this is how I put embeddings, Hugging Face embeddings into vectors. Okay, into vectors. This is what I did. So this is a question that you asked me. What does an embedding look like? So I got one idea. Embedding looks like this. So it's numbers like this, a feature vector. From the chunk, it generates embedding vector. So in this case, I have embedding document metadata. So if I go down, as an example, I reach the 20 chunk in this case.
And what does this number symbol?
Words. This is whatever it could be related. Okay, from all the things that we know in the world. Okay, it could be something like it's a masculine or feminine. It's the touchable object, virtual object, abstract object. It could be anything that we don't know. Okay, all those things might be covered. So the word, the document, I believe, is coming from here. So this is what the data is. Okay, so you see that this is the chunk that was used. And the title is this, and see the metadata. So maybe it's a description. Here it is. So it's coming from this document, and this is the sentence used for the purpose. Okay. So I'm able to get that information. If I'm able to get this information, you should be able to check the embeddings. I think this should be enough for you to start and get hands-on on this one. You are going to implement K-means, you know what it is, and you should be able to start loading the documents as well. Start with small, don't start with 10 documents, start with 2 documents initially, or 1 document, and then add later. Any questions?
So,
Yes.
we have to come up with these codes,
You need to,
so this Python. code.
yeah, you need to write on this. Some of it's already available on the website, right?
If the website to show those, we can just copy use one.
Yes, for this one you can use directly. So there is a PCA part in the assembly one. For PCA, you can also use the library, available library for PCA. Okay, so you can make this question on this. But this is the start. Question?
The distance.
K-means I can use the library.
K-means you need to implement it. K-means is the only part you need to implement.
So do we have to implement like distance from the vector?
Distance from the vector, no, you don't need to implement.
The distance measures.
You may use from the library. Okay,
So this is due when?
2 weeks. That's a lot. As I said, if you think that you need additional time, let me know. Next Wednesday, I can extend it. But if you haven't started by next week, you cannot finish. That's my. You should be able. You should have questions next week. And these are the challenges you are facing.
If you haven't started by next week.